Hello and welcome back. I got cut off in my last video, so I'll continue with the example I was about to do with the radicals. And again, to solve an equation with some radicals in it, what we'll want to do is isolate one of the radicals by itself and then get rid of it by, say, for instance, squaring it, raising it to the nth power if it's the nth root. So here I have the square root of x plus 5, so I want to get that by itself. So what I'll do is I will add the square root of x minus 3 to both sides of the equation. And when I add and subtract the same thing, those will cancel out. And then on the other side, I'll have 2 plus the square root of x minus 3. And now I have the square root by itself. So what I will do is I will square both sides of my equation. And when I square the square root, I will have an x plus 5 left over. On the right-hand side, I have a binomial that I am squaring. So we have a formula. So it'll be a squared, which will be 4, plus 2 times a times b. So this will be 4 times the square root of x minus 3, plus b squared. And the square root of x minus 3 squared is just going to be x minus 3. So let's simplify this before we do anything else. We'll have x plus 5 is equal to, I have a 4 and a minus 3, so that'll be plus 1. I have an x term, and I have this last one. Again, what I'll do is I'll move, I'll try to isolate my square root by itself so that I can square to make things go away. So here I will subtract an x from both sides to get rid of that, and then I'll subtract a 1 from both sides to get rid of this, to be left with the x and the x will cancel out. 5 and the negative 1 will become 4. I still have my 4 square root of x minus 3, plus x minus x will go away, plus 1 and minus 1, that'll go away, and I'm left with a fairly simple equation. I can divide both sides by 4 to have all my 4's cancel out, and I'll be left with 1 is equal to the square root of x minus 3. And now I can square both sides. And 1 squared is 1. The square root of x minus 3 squared will be x minus 3. And now I can add 3 to both sides to get that x should be equal to 4. Now, before I do anything else, I should check to make sure that this is an actual solution. So I'll plug everything back in here, and I'll have the square root of 4 plus 5 minus the square root of 4 minus 3. If I simplify this, 4 plus 5 is 9, and the square root of 9 is 3. 4 minus 3 is 1, and the square root of 1 is 1. And, oh, I get 2, which is what I should get. So this is, in fact, my solution. Next, we've seen how to solve these square root problems, or in general the nth root problems, but we can have x to powers that are sort of any rational numbers that we want. So what we'll do is we'll look at how to solve x to the m over nth power is going to be equal to some number k. And we'll also assume that m and n are both positive numbers, just to make things a little bit simpler. First thing that we'll do is we'll isolate x to the m over nth power by itself. And then again, if you want to cancel out raising something to the m over nth power, you raise it to the n over mth power. Again, what are we doing? Why we do this? Let's look at a couple of examples to see what will happen. If I have x to the m over nth power is equal to k, and I raise both sides to the n over mth power, what will happen? Well, when I raise a power to a power, I end up multiplying. And m over n times n over m, cancel, 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 is 1. And this is why we're doing it. So then I have x to the first power, which is just x. And then on the other side, I'll have, I forgot this, I should include that there. And on the other side, I'll have k to the n over mth power. Now, when you look at both of these solutions that I'm working out, when m is even, you'll notice that I get a plus or minus sign at the bottom. And if m is odd, you don't. This is because if m is even, essentially in the steps, you will multiply some numbers times themselves, which will cancel out negative signs. When m is even, we have to be careful, and we have to think, oh, there could be a positive root and a negative root. So we need to include both of them. When m is odd, the negative signs won't cancel, and we get whatever we get. So it's not something that we have to worry about the plus or minus sign. When m is even, the negative signs will cancel out, and we'll have to add them back in. At the end, we just check our solutions. So again, this is fairly straightforward. We just raise both sides to a power, remembering if we need a plus or minus sign or not. So let's do a couple of examples. So here I have 5x to the 3/2 power minus 25 is equal to 0. First thing, we want to get this odd power by itself. So if I add 25 to both sides, I will get 5x to the 3/2 is equal to 25. And then I need to divide both sides by 5 to get rid of that factor of 5. And I have x to the 3/2 is equal to 5. And now I get to undo this power by raising both sides to the 2/3 power. Again, when I raise this to the 2/3 power, all of my fractions cancel and I'm left with 1. The question is, do I have to have a plus or minus sign or not? What we're doing is we're looking at m, and m is what's on top of the fraction. If it's even, I add it. If it's odd, I don't. On top of my fraction is a 3. 3 is odd, so I don't add a plus or minus sign. And this is my solution. We can check this fairly quickly. If I have 5, and I take 5 to the 2/3 power, and I raise that to the 3/2 power, I subtract 25, what should I get? Well, 5 to the 3/2 to the, 5 to the 2/3 to the 3/2. Well, when I multiply my powers, this is why we're doing this, when I multiply the powers, they'll cancel. 2/3 times 3/2, 2's cancel, 3's cancel. I have 5 times 5 minus 25, and that's 0. So everything checks out. Let's do the same thing for this equation over here. I have x to the 2/3 minus 8 is equal to negative 4. So I will add 8 to both sides to get x to the 2/3 by itself. Negative 4 plus 8, this is going to be 4. And now I will take both sides and raise them to the 3/2 power. So I'll take 4 and raise that to the 3/2 power. Now again, I need to look at my exponent, look at what's on top, and I go, aha, it's even. Got to add the plus or minus sign. After that, I can simplify this a little bit. For instance here, 4 to the 3/2 power, this is the same thing as 4 to the 1/2 power to the 3rd power, since 3 times 1/2 is 3/2. And 4 to the 1/2 power, well, that's just the square root of 4, which is 2. And 2 cubed is 8. So this will be plus or minus 8. And you can go back and you can plug this in and you can check, and you'll see that they both work out. So x is either 8 or negative 8. The last equation that I want to look at is one that will immediately, you'll see this and think, oh, we have an x to the fourth power. That's pretty big, and maybe it's a little bit scary. But the one thing that I'll point out here is that we can simplify this a lot. What you'll notice is that I have an x to the fourth and an x squared. And an x to the fourth, well, that's just x squared squared. And then I've got my x squared term. And I have the constant term. So I have something squared minus 5 times that something plus 6 is equal to 0. Let's replace x squared with a new variable. Let's call this new variable u. And what will happen is this will simplify a lot. X squared is just u. So x squared squared just becomes u squared. X squared is just u. And oh, hey, look, this is a much simpler equation. We know how to solve quadratic equations. And in fact, this quadratic equation is factorable, which makes it really easy. So as I factor this, I want two numbers that multiply together to give plus 6. That when you add them together, you get minus 5. Negative 3 times negative 2 is 6. Negative 3 plus negative 2 is negative 5. So because we're multiplying two numbers together to get 0, one of the two numbers must be 0. So either u minus 3 is 0 or u minus 2 is 0, in which case I can add 3 to both sides and get u is equal to 3, or u is equal to 2. We're not done yet, though. Our original equation was in terms of x. I've solved for u. I haven't solved for x. We'll use our rule. I replaced x squared with a u. Let's unreplace it. So instead of u is equal to 3, what I mean is x squared is equal to 3. And again, instead of u is equal to 2, what I mean is x squared is equal to 2. And both of these are fairly straightforward. If x squared is equal to 3, x is either the square root of 3 or x is negative square root of 3. And again, if x squared is equal to 2, it either means x is equal to square root of 2 or x is equal to the negative square root of 2. So we have 4 potential solutions. And the one thing again that we want to do whenever these square roots come up, we want to check, are these actual solutions? And you could plug them back in here and see that each one of these 4 is in fact a solution.